Hello everybody, I hope you are doing well. In this session, I introduce the concept of H-index, H10 index and impact factor or other metrics in auto calculation. My name is Farzan Madadizadeh and it's my pleasure to being with you. In this session, we introduce the research matrices and give 6 or 7 number of these matrices is very important in research, such as H-index, H10 index, G-index, impact factor, and other matrices. What is the research matrix? Research matrices are quantitative tools used to evaluate the impact, productivity, and influence of scholarly work. They help institution, funding body, and researcher themselves assess. So productivity is how much research a scholar or institution has produced. Impact means how widely their research has been cited or used by others. Influence means the significance of work within its field or across discipline. Common type of matrices. You can see common type of matrices in this table. These are the list of our type of matrices are very common, and definition, strengths, and limitation. We will discuss about one by one in next slide. So I'll just read name of it: citation count, H-index, G-index, file weight citation index, eigenfactor score, SNIP, source normalized impact per paper. First of all, we discuss citation count. One of the earliest and simplest metrics is citation count, emerged with the development of citation index in 1960. It was invented by Garfield, the founder of Institution of Scientific Information and creator of Science Citation Index. So how to calculate it? Just add up the total number of citations across all of research publication. For example, if a scholar has 5 papers with following citation, to calculate citation count, we just need to plus it and add up them, so the total citation count will be 13. The next matrix is H-index. H-index was introduced in 2005 by physicist Jorge Hirsch. The H-index was designed to combine productivity, number of paper, with impact. It avoids overemphasis on either a single highly cited paper or a large number of uncited ones. How to calculate this index? Ranked paper by citation count, highest to lowest. Find the large numbers H such that H paper have at least H citation H. Example, citation count is 25, 8, 5, 3, 1. H index will be 3 because 3 paper have more than 3 citations. Another example in H-index calculation is presented here. Suppose a researcher have 10 paper with this citation. For example, In first paper, 45 citation, paper 2, 38 citation, paper 3, 30 citation, paper 4, 25 citation, paper 5, 10 citation, paper 6, 8 citation, paper 7, 6 citation, paper 8, 4 citation, paper 9, 2 citation, paper 10, 1 citation. So we want to calculate H index. First of all, you should sort paper by citation count, descending, especially descending. Compare rank with citation count. Then look for the highest rank R such that paper at that rank has at least R citation. So, such as this, first of all, we should rank paper. For example, 1 to 10 is ranks, paper, and citation. So look for the citation and rank number. Where is the line citation fails at rank here. Here 7, rank is 7, citation is 6. So in this table we show it. First rank 45 is more than 1, in 2 rank 38 more than 2, in 3 13 more than 3. So just in 7 citation number is lower than rank, so H index is 6. H index is 6 because in 7 rank the condition failed, and rank number in 7 is bigger than citation. Just in 6 is citation is 6 because in the 6th rank the condition is equal to what mentioned before. So H index is 6. Another index is G index, proposed by Leo Egghe in 2006. The G index improves on the H index by giving more weight to highly cited paper. It's especially useful when a researcher has a few very influential works. How to calculate? First of all, rank paper by citation, high to low, then calculate cumulative citation. Find the largest number G such that top G paper have at least G squared total citation. Example, citation count. Suppose the citation count is 20, 10, 5, 3, 2. In cumulative will be 20, 30, 35, 38, and 40. G index is equal to 4 because because 4 paper have at least 16 total citation. I will give another example to better understand it. So, rank paper by citation, calculate cumulative citation, find the largest number of paper that total number have at least G square citation. Okay, go to example. For example, suppose a researcher have 10 papers with this citation. In step 1 we will sort paper by citation, already sorted. find the largest G where cumulative citation is at least G square. So we calculate G square here: 1, 4, 9, 16, 25, 36, 49, 64, and 81, and 100. Okay. Look at cumulative citation. Where is the cumulative citation is bigger than G squares? In all of them is, it can be seen in all of them. For example, in cumulative citation in 10, in rank 10 is 169, is bigger than 100, so G index is equal to 10. Other index is I-10 index. I-10 index was introduced by Google Scholar in early 2010. The I-10 index is a simple metric using Google Scholar profile to show how many population have received at least 10 citation. It's very simple calculation. Count how many paper have larger than 10 citation. For example, citation count, suppose citation count is 15, 11, 9, 8, 10. I-10 index will be 3 because 3 paper have citation more than 10. Very simple. Journal impact factor is very important matrix developed by Eugene Garfield in 1970s. Impact factor was originally intended to help libraries decide which journal to be subscribed to. It later became a proxy for journal prestige. How to calculate IF or GIF? IF is more commonly in written. IF for year X is equal to citation in year X2 article published in 2 before years. For example, X minus 1, X minus 2. Citation in previous 2 years divided on number of articles published in 2 years, into previous year. So if today we want to calculate IF in 2025, we should back to 2023 and 2024, 2 years before, and citation in year published in 2023 and 2024 will be added up, and then it's divided by number of published in 2 years to 2023 and 2024. So total number, for example, total number of citation is 500 and total number of article is 100. So IF will be 5 and it means on average each article published in journal in 2023 and 24 were cited 5 times in 2025. 2025, yeah. Another example is presented here. For example, citation, suppose citation in 2024, we want to calculate IF in 2024 for a journal. We know that in 2022 citation will be 120 and 2023 citation was 180 citation. Total number of citation will be 300. So number of articles in 2 years. In 2022, 80 articles were published. In 2023, 300 articles were published. So total articles will be 180. Impact factor is 300 divided by 180 will be 1.67. So it means on average each article published in 2022 and 2023 was cited 1.67 times in 2024. Another metric is altmetrics. Emerging around 2010, altmetrics were developed by a scholar like Jason Prem to capture the broader impact of research beyond academic citation, especially in digital and public spheres. How to calculate? There is no single formula to calculation of altmetric. Altmetric aggregate mentioned form have no single formula. Social media such as Twitter, Facebook, Instagram, news and outlet, blog, policy document, monthly readers. Example, a paper received 50 tweets, 10 blog mention, 2 news articles. Altmetric score is equal to platform minus dependent algorithm assign weight scores. Is not very important. So the important metric in this session we introduce are H-index and impact factor. Field weight citation impact developed by Elsevier and for Scopus. FWCI adjusts for difference in citation behavior across discipline. It allows fair comparison between fields. How to calculate it? FWCI is actual citation received divided by expected citation for similar publication in the field. Example, a paper in economic receives 15 citations. Similar paper in the field average 10 citation. So FWCI equal to 15 divided by 10 means equal to 1.5. This is the above average. Eigenfactor score. Another metric is eigenfactor score created by Carl Bergstrom and Jeff Invest in mid-2000. The eigenfactor score evaluates journal influence based on citation network, similar to Google's PageRank algorithm. How to calculate? It uses complex algorithm to weight citation based on prestige of citing journals. Self-citation are excluded. A score are normalized so that the sum of all journal scores equal 100. Example, journal X has an eigenfactor of 0.5 because it accounts for 50% of total influence in citation network. SNIP, source normalized impact per paper, is another citation matrix developed by Henk et al. Adjusted citation impact based on citation potential of a field, helping comparing journal across discipline. How to calculate SNIP equals raw impact per paper divided by citation potential in the field. For example, journals Y has a raw impact of 2 and citation potential of 1. SNIP will be 2 by dividing them will be 2. So thank you very much for your attention and being with me. Hope this session will help you to better understand the meaning of search and will be professionally in search. Thank you.